Okay, let's look at problem 4.117. In the solutions that provided, the answers are actually wrong on this one, so I wanted to do this problem, have you guys have a look at it. It's a good example of how to do these problems. So we have a rectangular plate that weighs 75 pounds and is held in position by these two hinges, and we're supposed to determine and a cable here at E. We're supposed to determine the tension in the cable and the reactions at A and B. So let's start with a free body diagram. So we have, I like doing them like this. The book does them consistently the other way. I struggle to do it at that angle. So I'm going to draw it like this because it just makes more sense to me. So you have a plate here. Here in the middle you have a weight of 75 pounds. Here at A you have a force AY, AY, AX, and AZ. Here at B you have the same deal. BY, BZ, and you could have BX, but that is defined as 0 where it says that assuming that the hinge does not exert any axial thrust. So that means BZ or BX is 0. And then lastly, you have at this point here E, you have a force coming off there, and it's called EF. We'll call it EF. Okay, so first thing I want you guys to do when you're doing these problems is to clearly define everything, right? So EF, how would you define the EF vector? EF is the magnitude EF times the lambda, the unit vector in that direction, right? So in the x direction from E to F, it goes 8 in the I direction, it goes plus 25 in the j direction, it goes minus 20 in the k direction, right? All that by the square root of 8 squared plus 25 squared plus 20 squared, which is 33. So this ends up being EF over 33 times 8I plus 25J minus 20K. Okay, so that's EF. And weight, just for clarity, is just minus 75 in the J direction. And now let's look at our vectors. So we're going to take the moments. And where are we going to take the moments from? Again, we can take the moments from anywhere we want. We could do it from here. We could do it from here. We could do it from here. This wouldn't be the craziest thing in the world. But I'm going to do it from point A. Why am I going to do that? Because point A, we get rid of 3 unknowns. Okay. So given that I'm going to take the moments from point A, let's do the R, the radius from A to B is, that one's pretty simple. From, if this is a total of, and this is where they mess up in the book, this is a total of 38 inches in that direction. And so you take off 4 here and 4 here, so you're looking at 30. So from here to here is going to be 30 in the I direction plus 0J plus 0K. Okay, I lied. That's not where they messed up. They messed up on the other one. So R from A to E is going to be, in this case, it's going to be 26 in the I direction. It's going to be plus 0 in the J direction, but it is going to go plus 20 in the K direction. And then R from A to the CG, this is where they goofed in the solutions, is from here to this point right here, right, or to this point right here. It's, so that point 38, so from here to here is going to be half of 38, which is, what is that, 19? And that's what they put in the solutions, but you have to subtract off this 4, so that's going to be 15 in the I direction. It's going to be, again, 0 in the J, and it's going to be plus 10 in the K. Okay, I like doing this because now I can go through and I can do all my work, and I have all the answers really clearly here. So I'm going to say sum of the moments at A is equal to 0. So at A, what do we have? We have R from A to B cross the forces at B plus R from A to E cross the force at E plus R from A to CG cross the forces at CG, which is just a weight, right? So let's go through and do this. We have our I, J, K from A to B is right here, right? We wrote it down, that's why we did that. So it's 30, 0, 0. And the forces at B are going to be Bx, oh sorry, that which is 0, By, and Bz. Okay, fair enough. Now plus our next determinant I, J, K. Our R from A to E, that's supposed to say E, is 26, 0, 20. And our force at E is, I'm going to pull this out. I'm going to put EF over 33 outside the thing because it's just a little too complicated to put in there. And it's 8, 25 minus 20. And then all that plus our next determinant is I, J, K. The R from A to the CG is 15, 0, 10. Again, that's where it's wrong in the solutions. And that is going to be 0 minus 75, 0. This is equal to 0, right? This is the equation. So sum of moments is equal to 0. So then it's just a matter of doing it. So let's look at the I. Let's go through and do it. Again, I'm going to write it I times, I'm going to do the I term of each one. I'm going to do the J term of each one. So on this one, it's going to be 0, so 0, right? Plus the I term of this one is going to be minus 25 times 20, right? This minus that. But don't forget the thing that's multiplying them all, EF over 33. And then the last one, the I term is 0 minus M, so it's going to be minus minus, so plus 750, right? So that's the I terms. And then the way I do determinants, I'm going to say minus the J terms, which are, so this J is 30 BZ minus 0 plus this J term is going to be, so I'm going to put the EF over 33 times the J term is going to be 26 times minus 20. I'm going to put this in a big bracket then. So 26 times minus 20 minus 8 times 20. Big bracket around that, right? Then the J term on this one is 15 times 0 and 10 times 0. So it's going to be plus 0. Plus the K terms, which are going to be on this one 30 BY, 30 BY on this one, plus EF over 33 times the K term of this 26 times 25 minus 0, so 26 times 25. And then the K term on the last one is going to be plus 15 times minus 75, all that. Okay, so that is your equation. Your I terms, your J terms, and your K terms. So the way I solve these is, the reason I wrote it like this is because this is going to give me an equation. Like I said, the I terms equal to 0, the J terms equal to 0, and the K terms, right? So you're going to have EF over 33 times 20 times 25, so there's a minus sign on there, is equal to minus 750. So therefore, EF is equal to 49.5 pounds. So there is your first answer. That you just figured out your tension in your wire is 49.5. Now let's look at the J terms. Right? So 30 BZ plus 40, it turns out 49.5 divided by 33 is 1.5, so I'm just going to write that 1.5 times all these numbers. I did this on the side, and it ends up being minus 680 is equal to 0. So that tells us that BZ is equal to 34. And then this one right here, we're going to use this equation. So 30 BY plus, and then 1.5 times 26 times 25 minus 15 times 75 is 1125. 1125 equals 0, and that gives us that BZ is equal to, okay, I goofed a little bit. This is not BZ, this is BY. And this is therefore BY, that makes more sense, is equal to 5. So BZ is 34, BY is 5, BX is defined as 0, right? It was given as no axial thrust. Okay, so now we have to figure, whoa, hey, none of that. We have to figure out what AX and AY and AZ are. So how do we do that? Well, let's start with the sum of the forces in X equals 0, right? So AX plus EF in the X direction plus BX is equal to 0. Well, this is defined as 0. So AX is equal to minus EF in the X direction. So it's equal to minus EF over 33 times 8. And again, I'm just getting that from right here, this part of the equation. So it works out that therefore AX is equal to minus 12. Okay, so then we're going to do the same idea. Sum of the forces in Y equals 0. So AY plus EF in the Y direction plus BY plus the weight is equal to 0. So AY is equal to minus weight minus EFY minus BY. So it's equal to minus and minus 75. So it's 75 pounds. EF in the Y direction is, we're going to look at it right here. It's this, again, I'm looking at this one right here and this one right here. So it's 25 over 33 times EF. EF in the Y, so minus 49.5 over 33 times 25, right? Minus BY, well, I found BY right here. It's just minus 5. So therefore, AY is equal to 32.5. Here's AX. And lastly, I'm going to scoot over here. Sum the forces in Z equals 0 is going to give me AX plus EF in the Z direction, sorry, AZ, wow, plus EF in the Z direction plus BZ is equal to 0, and that tells us that AZ is equal to minus 4. And that's your final answer. So if I was, do this on chart, I would say that EF is equal to 49.5 pounds. AX is equal to minus 12 pounds. AY is equal to 32.5 pounds. AZ is equal to minus 4 pounds. This is where I like putting BX is equal to 0 pounds. It's just to make it clear that there could be a force there. It's just we're defining it as not being there. BY is 5 pounds and BZ is 34 pounds. And that's it. That's your answer. So again, the key with this is you can take the moments anywhere you want. Might as well take them somewhere that makes life easy. Taking about B would not be unreasonable either, but we take the moments. Gives us 3 of our 6 equations, and the other 3 equations are going to come from the sum of the forces in X and Y. And that's that.